Welcome back. Today we will be starting lesson 2.2. We'll be talking about graphing inequality equations. Now last week we were working on problems that were graphed on a number line, such as problems like x greater than 3, x less than 7, and we are putting these numbers on a number line, 3, 7, and we were graphing them. Open circle, open circle. We're graphing problems on a number line. Now today we're going to be, again, tackling graphing, but this time the problems that we're going to do have an x and a y. So when we graph them, they're going to be on this coordinate plane. So we're going to get problems like this. So we're going to have to do three things. We're going to have to graph them, graph the line. We're going to have to determine how that line looks, that's solid or dotted. And then 3, we're going to have to shade. So let's write those steps down. We're going to have to graph the line. 2, we're going to have to determine what type of line it is. So we'll say type of line. Type of line. Is it dotted or is it solid? And then 3, we're going to have to shade. Are the 3 things that we're going to tackle within this lesson. And if we can graph the line, that's going to be honestly the hardest part. So let us look at this first problem. We have x plus 3y is greater or equal to 6. So if we consider that like we have in the past, if that was an equal sign, 3y equals 6, we'd have to decide how we're going to solve it. So a problem like that, we'd start by subtracting the x over. 3y equals negative x plus 6. We divide everything by 3 as we've done in the past, and we'd end up with y equals negative x over 3 plus 2. So now it's in that form, that y equals mx plus b form from last week. We've got it in that form where we can now graph it. We know that b, that y-intercept where we start, is 2. And our slope, in this case, that negative x over 3, that's going to be negative 1 over 3. That's going to be my slope, my rise and my run. So if I was going to graph this line, I'm going to go down 1, right 3. Down 1 to the right 3, down 1 to the right 3. So there we go. We've got the points. We can now make the line. So step 1 in our equation of can we graph it? Yes, we have. We put the points. We figured them out. But now step 2 was, is this going to be a solid or a dotted line? A solid or a dotted line. Well, that comes down to what that inequality sign says. So in this case, it is a greater than or equal to. If you have a greater than or equal to or a less than or equal to, you're going to use a solid line. So if I was going to make my line, it's going to look something like that. If that inequality would have just been a less than or a greater than, that's when we're going to use a dotted line. And we'll see that here in a second. So awesome, we have the line. This is the same as when we were doing those linear inequalities. Did you use an open or a closed circle? Is it a solid or a dotted line? So we've graphed the line, check. We've determined the type of line, check. Now we have to do type number 3. We have to shade. We have to shade. This is the same as drawing that arrow to the left or the right. We have to shade either above or below that line. And now what I've always found the easiest is to pick a point and try it out. So for me, I like to pick the point 0, 0. You can use any point you want, but I take that point as 0, 0, and I plug it in for x and y. If I come up here and do 0 plus 3 times 0, is that greater or equal to 6? Well, essentially it's going to be, is 0 greater or equal to 6? Well, no, that's not true. That's not true. So I want to shade, because 0 is not a solution. 0 does not work for this. I'm going to shade my graph so that I don't include that 0. And that would be my solution. That would be the final answer. We put the equation to slope-intercept form. We put some points to draw the line. We determined if that line was solid or dotted. And then we determined if we had a shade above or below. Now, a lot of times you can sort of use the thought process of if it's a greater than sign, you shade above. If it's less than, you shade below. But still, I personally like to plot some points. So let's do another one. Again, I want to get this in that form, y equals mx plus b. So for this problem, what I would do is I'd subtract that 3x over, minus that 3x, minus that 3x, and I'd be left with the equation y greater than or equal to negative 3x minus 7. So now I can plot my points. I know my y-intercept is that negative 7. I know my slope is going to be a negative 3. So now I can plot my points. I can do negative 7 gets a point. My slope of negative 3 is negative 3 over 1. So I can go down 3, 1, 2, 3 over 1. I have some points. So now the decision is to say solid or a dotted line. Well, if we look at the original problem, because it was a greater than sign or a less than, that has that equal to portion, we know we're going to use a solid line. So I'm going to sketch this with a solid line. Let's see if we can make this line relatively straight, something to that extent. The line has been graphed. Now my final step is I need to shade. Again, I like to test the point 0, 0. So if I went 3 times 0 plus 0 is greater or equal to negative 7, testing that point 0, 0. Let's see, this is 0 greater or equal to negative 7. Well, is that true? Is 0 greater or equal to negative 7? It is. 0 is greater than negative 7. So now when I shade, I want to shade the side of the graph. I want to shade to the side of that line that has 0, 0. So I'll shade the right side of that graph. So again, we put it in slope-intercept form. We found the y-intercept and the slope. We plotted those dots. We determined if it was a solid or dotted line. And then we shaded the appropriate side. Let's try one more problem. Again, we want to get this in that y equals mx plus b form. So I'm going to start by subtracting that x over. Negative 2y is less than negative x plus 2. Now I'm going to divide everything by that negative 2. Divide everything by that negative 2. When I write my final equation, now because I divided by that negative 2, I'm actually going to switch my inequality sign. And I'll have my equation y equals mx plus b form. That means the b value is going to be negative 1. And my slope, that x divided by 2, is the same as 1 over 2, 1/2. So plotting that on my graph, I start at my y-intercept, my negative 1. And I do my slope, up 1 to the right 2, up 1, right 2. And I like to put as many points as I can. That last problem, I could only put the 1, but this time it looks like I could put a couple more points. So I put a few more points there. There we go. We have some points. So part 1, the line is graphed. Part 2, is this going to be a solid or a dotted line? Well, because it's just that less than, the equation does not have that equal to portion on it. It's just that less than. We are going to use a dotted line in this case. Something like that. It's a dotted line. So it's a dotted line, or a dashed line is another way to think of it. It's a dashed line. And the final step is, which way do we shade? Again, I like to test that point 0, 0. It's, I think, an easy one to use. So if I do 0 minus 2 times 0 less than 2, solving that out, is 0 less than 2? Is that a true statement? Is that correct? Is 0 less than 2? Yes, it is. That is true. That is a statement. That is a correct statement. So I want to take this graph and I'm going to shade it on the side that includes it. If the equation, if 0, 0 did not work, we would shade the other side, so we didn't include the point 0, 0, but because the point 0, 0 does work, I'm going to shade to include that line. So there you have it. We have graphed inequality equations. We start off by treating them as normal equations. We find the slope and the y-intercept. We graph the line. Once the line is graphed, we determine if it's a solid or a dashed line, and then we have to shade. I encourage you to try a few more problems. Moving forward, we will start to graph multiple inequalities in one graph to see what we call a feasible region. But for now, we'll start with a single equation and get them graphed. Best of luck, and please let me know if you have any questions.